Hello students, today we will be studying about covalent network solids from class 12, chapter 1, chemistry solids. In the previous sessions we first saw about molecular solids, then in the second session we saw about ionic solids. In the third session, which is the previous one, we saw about metallic solids, and now yes, we are going to end all about crystalline solids, and this is the fourth one. This is covalent or network solids, and with this we will end the classification of crystalline solids. We will be ending that topic. So aren't you guys excited to finish this off, right? So let's quickly check over what these are. Okay, so we always ask questions in study, right? So let us ask the first question. What was the first question? What are the constituent particles, right? That is what we always ask first to any crystalline solid. What are the constituent particles? A second question was what kind of bonding is seen in this solid. Okay, so type of bonding. What is the third question? The physical nature. Okay. Fourth question about the melting and boiling point. Here also, just like metallic solids, we will only study about melting point. Boiling point we are not going to look at. Okay, so we will see what kind of boiling point, we will see what kind of melting point is there. Then about their electrical conductivity. And some of the examples. These 6 questions, just answer these 6 questions and this is done. Okay, this is going to be really simple. It's quite simple. There is nothing hard in it. Okay, so what are the constituent particles? The constituent particles here are atoms. Okay, constituent particles are atoms. What kind of bonding is seen here? Covalent or network solids. So it's surely covalent bonding. Covalent bonding is seen, and this bonding is strong and directional in nature. Okay, the bonding is strong and directional in nature. Here in this covalent bonding in network solids, they are quite strong and they are having a direction. Okay, they are directional in nature. And the atoms, because as they are very strong, okay, as they are very strong and as they are directional in nature, the atoms here are held very strongly at their positions. Because of these two factors, the atoms are held strongly. Atoms are held strongly at their positions. And what is the physical nature? Physical nature, they are hard and brittle. Melting points, it's extremely high. Okay, very high, extremely high melting points, and because of this high melting point, it may even decompose before melting. Okay, because of the high melting point, they have a chance of decomposing before melting. They can decompose before melting because of the extremely high melting point. Electrical conductivity. These type of solids are insulators. They are insulators, and they will not conduct electricity. So, and they are also called as giant molecules. Okay, these type of solids are also called as giant molecules. Now examples. Here I am dividing the examples into two. Okay, examples of insulators, examples of examples of conductors. Now you might be wondering, I said before that electrical conductivity, they are insulators, and why am I giving examples of conductors? But there is an exception for one molecule here. Okay, here only graphite, okay, not only graphite is having covalent, graphite is the only covalent solid which is a conductor. Graphite is the only covalent solid which is a conductor. So when you study this, here you have to include in the examples graphite in under conductor. Okay, under the example of conductors, only graphite. Now coming on to examples of insulators. Okay, so here for insulators we have diamond and silicon carbide. We have SiO2, Al. There are many AlN. Okay, so these are the examples. I'll just erase the other points so that you can see clearly. Okay, so these are the examples: diamond, silicon carbide, SiO2, AlN. Okay, and examples of conductors are graphite, and yeah, that's all. That's the only example of conductors. So what did we see now? See, this is what we looked at right now. Covalent or network solids. Constituent particles are atoms. Bonding is covalent. Physical nature is hard. Melting point, physical nature, it is hard and brittle. Okay, it is hard and brittle. Melting point extremely high. Electrical conductivity, they are insulators and they will not conduct electricity. And as the melting point is very high, because of which before melting sometimes they will decompose. They may even decompose before melting. Some of the examples of insulators. Okay, these are the examples of insulators. Silicon carbide, diamond. Okay, all these are examples of insulators. Conductors, we have graphite. Okay, examples of conductors, graphite. So if you get this question in your exam, write a short note on covalent solids, covalent or network solids. How will you answer it? This is how it should be. The constituent particles are atoms. Bond seen here is covalent. Covalent bonding is seen. Covalent bonding is seen and they are strong and directional in nature. And are strong and directional in nature. Therefore, the atoms are held very strongly. The atoms are held very strongly at their positions because the bonding, because the covalent bonding is quite strong and directional. So the atoms are held very strongly in their positions. Next we were talking about physical nature, right? Physical nature is hard and brittle. Physical nature is hard and brittle, and they have high melting, extremely high. Okay, very high melting and boiling point. Very high melting point. Okay, don't write boiling point. I've seen many students when they write the answer, they by mistake they just go along. When they write, they have very high melting and boiling point. If you write that, you won't get mark. Okay, that how much ever mark distribution is, they will cut your mark. Okay, even if you have written melting point is high, you should only write one, melting point is high. Don't include boiling point here. Okay, so the melting point is quite high. So next, what did we study? The melting point is very high, and as the melting point is very high, they may even decompose before melting. And what kind of conductivity? They are insulators. Okay, here we are taking as a whole they are insulators, but there may be exceptions, as the one we saw in graphite. So they are insulators and they do not conduct electricity. They are insulators and do not conduct electricity, and they are also called as giant molecules. And the example of insulators, what were the example of insulators? We studied diamond, silicon carbide, SiO2, Al, and all those. Okay, then examples of conductors are, there is only one, which is graphite. Okay, so write a short note on covalent or network solids. The constituent particles are atoms. Covalent bonding is seen and are strong and directional in nature, and because of which atoms are held very strongly at their position. Physical nature is hard and brittle, and they have very high melting point and may even decompose before melting. They are insulators and do not conduct electricity. They are also called giant molecules, and examples of insulators are diamond, silicon carbide, SiO2, Al. Examples of conductors are, it is graphite. And we should be very careful here. Very high melting point is only there. When we write the answer in that flow, we'll also write boiling point, but your marks will be reduced. So be careful. For covalent solids and metallic solids, we are only checking the melting point. Only for ionic, it has both melting and boiling point. All right. So this is all about covalent or network solids. And if you have any doubts, please put your doubts in the comment section, and I will surely reply to your queries. And if you have understood everything, then it's really good. So that's all for today, and next session I'll be coming with some questions based on what we studied right now. I'll bring some questions based on classification of crystalline solids. Okay, so let's see in the next session. Till then, stay tuned. Bye bye.